Evan, you should be good to go. Thank you. Yep.
Howdy, guys. I wanted to talk a little bit and introduce myself. My name is Evan Oslick. I will give a little bit more detail in a little bit. My real expertise right now has been in application security, more around software assurance and that type of regard. The topic that I'm going to talk about today is kind of comparing sports teams and software assurance. But for starting, anybody actually like sports? Here, watch it, play it. Sports.
Software assurance. What do you mean by software assurance?
Basically setting up a software security program in a company. So incorporating rules for dynamic analysis, static analysis, running pen tests, doing training for development communities, and running vulnerability assessments as well. So really just that whole encompassing program, that's what we're talking about. So who am I? I started out as a software engineer back in the 90s. Then in about 2004, I wound up turning into application security. And I'm also a big sports fan. I love volleyball, I play it. Also like watching hockey, football, baseball, and not necessarily very good at it, but I do enjoy it a lot. And one of the things that I've noticed about the application security space is that everybody tends to push risk and that type of conversation. And so the whole premise of this talk came about when I was watching the movie Miracle. Are you guys familiar with that movie at all? It's about the 1980 U.S. Olympic team. And this is a team that was supposed to get crushed by Russia and wound up winning. The coach, Herb Brooks, was building out the team. And when he was doing it, one of the biggest scenes that was in there that struck this talk is he's discussing how they're going to plan their strategy for beating the Russians. And the Russians are this great professional team. They always brought in professional players. And back in the 80s and the earlier years before professionals were allowed in the Olympics, the U.S. was bringing in college players. And one of the things that he said was, we're not going to give them time and space. We're going to attack the players. We're not going to sit by. And in order to do that, we need to have the right players there. And from that point on, it was about building out the team to fit that mold. So again, when I was looking at this, one of the things that struck me is, as security people, we tend to push the same discussion over and over again. And we all know the definition of insanity: doing the same thing over and over again and expecting different results. We constantly hear about ROI, litigation, brand image, and breach disclosure as basically a mechanism for driving the security process within an organization. And that tends to fail a lot more than it really should. And one of the things about sports is that you don't sit there and hear a general manager or an owner sit there and say, yeah, we're not going to have an offensive coordinator because, well, we really just don't need it. We don't need to spend the money. The ROI is not there. They build out a team and they build out the infrastructure in that team to be as efficient as they possibly can. And I think that is kind of the approach that we need to start having in security, rather than sitting there and doing the ROI mentality. Is we need to build out the team. So again, one of the things that we'll talk about is we'll kind of look at the roles that are played within the whole process. You know, from an ownership perspective at a sports team, is kind of like the owner of the business unit, the one who's driving the project. Then you have your managers, your general manager, your coach. They're kind of like the architects and the
giving tours, working here. Okay, sorry about it.
And the architects of the project. Next, you got the staff. You know, on a sports team, you have people who range from the offensive coordinator again in football. You have a pitching coach in baseball. Hockey, you even have skating instructors to help players with their skating stride, and all sorts of other things like the bat boy and the stick boy and the ball girl. You know, you can look at these as your affiliated assistants. So you've got like kind of your QA people, your application security people, and even your tech lead is kind of that. So when we're looking at this, you know, you look at a sports team, and the person who's really driving everything is the athlete. Well, in the software engineering world, you have the developer. Clearly, he's an athlete, right? Without having that developer build out the software, you have no product. So one of the things that we have to look at is how does this process going to work? Well, you know, when you look at a sports league in the teams, what they generally have is they have a training camp where they're, you know, where they get everybody together at the start of the season, start reviewing everything, and go from there. Next, you'll have your practices through the course of the season to kind of work on some things, and then you'll go into some scrimmages against other teams, you know, kind of light type practices, and then you have the game day. That's where everything goes live. So when you look at the training camp, the first thing that you're going to look at is the teams are generally trying to learn the playbook. They're trying to understand the plays. The coach is basically saying, we're going to run this scheme, we're going to put in this type of offense, and we're going to go from there. When you look at a software assurance program, the playbook is kind of similar in that you want to sit there and go, what are our coding standards that we're going to set to? What are the processes that we're going to have in place from a security perspective in terms of, you know, you're going to run through static analysis, you're going to run through dynamic analysis, we're going to do architecture risk assessments, and we're going to do penetration tests, we're going to do vulnerability assessments, and this is the process of how we're going to deal with remediation. Everything that is going on, everybody within that organization needs to understand, just as everybody in the organization of a sports franchise needs to understand what the goals are and how the team is going to function. The other factor that is generally about training camp is you're sitting there trying to get the team ready to play. You know, you're doing your, you know, in football they have the two-a-days. In baseball, they go through spring training and they're constantly doing throwing drills, they're doing hitting drills, and they're doing everything. That's pretty much what you're trying to do. This is your foundation from a software assurance program where you're trying to basically get everybody up to speed in what you want to do. Things like developer training. You know, you want to sit there and tell them, you know, coding while trusting client input on a network-based system, not a good idea. Don't trust your input. It's where you're implementing your security processes of where are we going to actually do this testing that we want to do? How are we going to do it? Which software packages are we going to do? Let's get everybody up to speed on the software packages. The next thing that you're kind of doing is you're starting to look at your weaknesses in your strategy. You know, as a coach, you're kind of eyeing, you know, what your developers are, what your players are good at, where the system weaknesses are. This is kind of like where if you were doing an architecture risk assessment, you got to look at it at a high level. You kind of go, okay, well, I see I've got my website is talking to a database from a third party. Well, I kind of don't want to trust that data because I don't know what's going to be in that third party system. Whereas if I'm looking at it from an internal perspective, it could very well be, hey, you know, we're going to trust this data because we've scrubbed it or we know where that data is coming from. Another aspect of it is kind of threat modeling, kind of taking an approach of where could it possibly be somebody taking advantage of our system. In hockey, a lot of times what you'll see is you'll look at how the defense lines up on their side of the ice, and they'll be like, where is the open area? One of the scenes in Miracle, again, is, you know, he's talking about when they're bringing the puck, Herpros is talking about when he brings the puck into the offensive zone, it's where is the open guy going to be based off of what the defense is going to do. So it's kind of a similar mold. That brings us ready to practice. Yeah, this is how I would probably end up on hockey skates, flying around doing nothing. The whole point of your practices is to kind of work with coaches to improve different skill sets. A lot of times in football, you'll see quarterbacks working with the quarterback coach, working with their form, trying to learn how to read defenses and look where potential attackers are coming from the defensive side of the ball. Like I said, I played volleyball a lot. I never played professionally or in college, but one of the things that they offered at school was we actually had a volleyball class, and our coach would sit there and basically work with us on the individual skills for passing, for setting, for attacking, for spiking the ball, for blocking, for reading where the player is going to be. These are very important aspects, and it's got to get ingrained into the player's head. This is where you need to go. It needs to become second nature. Similarly, in the case of a developer, there's a lot of tools out there, and I'm not going to go into the names of them for vendor's sake and who my clients are, that plug into the IDE, developers can code, and similar to a compiler, they'll sit there and alert the developer of, hey, this API is an unsafe API, or this API is one that you should definitely not use, and they'll provide alternatives, or they'll also provide ways to record, or ways to tell the developer, this is how you can protect yourself if you want to use this API. A prime example is SQL. When you're doing a SQL query to the database, if you're not using parameterized queries and you're just using an execute query call, these plugins will sit there and say, remember, use parameterized queries if you're using dynamic SQL. They won't flag it as a warning, or flag it as an error and prevent you from compiling, but they're going to constantly alert you on what APIs are hazardous and dangerous for a developer to use. The next part of practice is kind of doing a walkthrough of the playbook. They'll sit there and they'll work out, okay, we're going to run X play, or we're going to do this drill or that drill. And this is kind of like where if you're trying to get a feel for how your system is doing overall, you're going to want to run a static analysis tool across your entire code base. This is going to give you a rough idea of how your code looks and how and what remediation tactics need to get done. This static analysis, and as well as the rules for the developer plugins, should be run off of the rule set that is developed early on in this process. So if you have a rule that says, okay, any SQL injection warning that this analyzer would fire, if that analyzer is firing it on if that source is a database and it's internal, then we're not going to worry about it. If it's from a file, then we're going to flag it. If it's from user input, then we're going to flag it. This is all where everything kind of integrates in together. So you're kind of getting an overall view of how your code looks from that perspective. Now, one of the things that I want to say at this point is we're going to talk about dynamic analysis in a little bit. From a software assurance program, you need both. Everybody has their favorite interview question when you're going on an application security question interview. Which do you prefer, static or dynamic? The correct answer is both. If you had to choose one or the other, that is purely a personal opinion. They both have their faults. They both have their pluses. So usually next up, you'll run into some scrimmages. The thing about scrimmages is they're not real. You do something like that in a scrimmage, yeah, your coach isn't going to be happy with you. One of the things that you're trying to see is you're playing a different team. So you're kind of getting a feel for how the opponent is going to attack you. This is a little different than if you were to look at like the OWASP top 10 lists, or those lists which are standard, you can kind of go against them. This is kind of where you're looking at manual vulnerability assessments. You don't necessarily, when you've gone through the process of, hey, I've potentially got a vulnerability in this spot, but I'm not quite sure. This is where somebody else, where you're going against the red team, they're going to come in and they're going to try things that you probably would not have thought of. But at the same point, they're not out to actually own your system. They're here to tell you exactly what happened, and it allows you to kind of make an adjustment and go from there. So it's, again, you're not looking to have somebody come in and own your system. These are generally done in where you're doing it in staging environments. You're not running it live on your production system. If you do run a vulnerability assessment on your production system, you're making a mistake. Some of the tests are going to run query. Some of the tests could run actually execute vulnerabilities, and you could wind up crashing your system. You really don't want that happening in your production system, which is why you do it kind of in a staging environment. Again, the next aspect is remediation, and you've kind of got to build this into your process. What will happen in a sports team is they'll go back to the chalkboard or the drawing board of the playbook and kind of make some tweaks and adjustments to how the playbook, how that play is run, or how that environment is set up. So it's kind of a way for you to gauge how your system is running, where you're going, and it also gives you a chance to see how your remediation process works. And then you're on to game day. A lot of times what you'll hear about during the game is about coaches making adjustments. What's happening? The coaches usually have a game plan for how they want things to work. Well, during the game, the opponent makes it so you might have to make changes to that. Maybe you're not executing as well as you would hope, and maybe your players aren't performing up to speed. So you kind of make tweaks. You're either making tweaks to your players or the play calling or something like that. You're not necessarily going to have things work the way that you expected based off of the way they worked in practices or in scrimmages. They're human beings, things happen. We're in computer systems, things happen. You expect you expect an application to run one way in a Java container. It may work that way on one Java container, and then the other container, it may work somewhere different. You don't know. You would like to think that they work the same, but they don't always. So when you're looking at this, one of the things that you could have is a web app firewall. Now, nobody will tell you that a web app firewall is the ultimate solution. It isn't. But what it does give you is the ability to buy time, to actually put the fixes in, get the fixes that need to get done correctly into the code, and allows you to monitor and protect your website or your application to a certain degree. The other thing that this kind of that will happen during the games is you've got a lot of video analysis going on. The teams are recording their games. This even happens in high school, and it's kind of like an audit trail. You can kind of gauge how different teams are playing. You can kind of gauge how different players are working. Similarly, in a software development model, if you have a very good audit trail in your application, you're going to be able to tell how people are attacking you. You're going to be able to trigger alerts. You've got information with PI that collects PII in the system. Well, you want to basically flag as much of that access as you possibly can without actually logging the PII data to a file. That would be bad. Similarly, with usernames and passwords, you want to make sure that you're logging all the activity that occurs around authentication and authorization, and anything that deals with changing of credentials, changing of personal information and contact information. You want to notify the user about it, and this is basically kind of a way to prevent, kind of a way to track how things are going. It allows you to see what's going on in your system and make adjustments accordingly. So at a high level, that's kind of what we were talking about. So as I mentioned before, a lot of times what you'll hear about is ROI. Well, ROI is important, but the caveat to this is at any level of players, your high school team's not going to spend as much as your professional football team. Your intramural leagues aren't going to spend anything. Well, the great thing about this is there are a lot of tools out there that are open source and free. Even some of the vendors have free versions of their software. So you can implement these tasks, these processes, at a very low cost. And one of the talks actually that I happened to catch that's going to be up at the OWASP USA talk is actually about implementing open source software for a software assurance program. I'm really curious to see how that goes. Some of the the tools that they talk about it'll be interesting to see what the reviews are on those and how that goes. So while ROI and income and making sure you're not spending an excessive amount of money to protect your asset is important, I think that when we approach things as a way of doing that, it kind of defeats the purpose of we want to build a team. We don't want to build out this defensive mentality of, you know, if you don't do this, you're going to wind up where your brand is going to be ruined. We should really try to get away from that. So some of the other things as I was doing this kind of came out, and I was wondering who had the bigger ego, the developer or the athlete? It's kind of an interesting thing. The developer a lot of times will want to help, but they're trying to deal with the business rules. So they want to learn about security. They want to learn about, you know, different functions and ways of helping people. But the athlete relies on their coaches for improvements. Yeah, they're kind of up there. They're like, I'm the best. I got this. It's all me. But they tend to accept the process of going through and walking through with coaches and trying to improve themselves in a way that I don't think I see with development communities. Another aspect of this is complexity. So, you know, when you look at an athlete and you look at sports, you've got a interesting thing. You know, take baseball, for example. The best player in baseball maybe gets a hit 1 out of every 3 at-bats. The other 2, they're getting out, they're walking, whatever. Their success rate is very low. And the reason for that is because of the complexity of the event and the complexity of the task at hand. From the development community, and the software engineering community, it's not that much different. We're working on very complex systems. You know, you've got major amount of components interacting, you've got databases, you've got files, you've got operating systems. You try to move your application and port it to another operating system, well, depending on the language that you're using, the way that language is implemented on the second operating system may be slightly different in some very interesting ways. So there's no guarantee that what you think is going to work is going to work in another operating system. You look at other areas of engineering, such as architecture, yes, it's complicated and complex, but there's a finite number of variables that are going to exist. You look at it from a software engineering perspective, that doesn't hold true. So maybe it's a little bit of acceptance of this difficulty that allows us to get away from doing as much testing as we should. But in the end, you know, we need to be okay with having the mistakes, but we need to address those mistakes as quickly as possible. And, you know, so that's, I was hoping to get a little bit more interaction, but that's pretty much where I was at. Let me know if you have any questions. Yes?
What about penalties?
I'm sorry.
Penalties in terms of drawing parallels between.
So if you were looking at like penalties, I think that the way you would look at that, I think that from a penalty perspective, it's important that developers and the security personnel learn from their mistakes. I would not say that if you made a mistake, you should get fired or suspended or things like that. But I think that there definitely could be more remediation type stuff. So if you sit there and you know, don't follow the processes and plays that we have in place, that you have to go through more training, or you have to be mentored more, or you have to do more paired programming, or things like that. So there's definitely a parallel there to a degree.
What do you think of peer review as far as code analysis versus, say, dynamic or static analysis? If that becomes a closed process where the developer is the only one that sees those results, where I'm going is, what is the most effective way to get better code from the developer?
A combination. Peer review is definitely a good thing to do, especially if you're pairing senior and junior developers, you definitely get that. I actually used to really be nervous about doing paired programming. And in one of my recent jobs as a pen tester, we actually had QA processes, and what they actually did is we shared screens with our leader, and they were kind of monitoring what we were doing. And believe it or not, if you have the right person as that mentor, the person who's being mentored or being watched over and paired up doesn't even think of it as they're being watched over. You've got to make sure that you have both the right person doing the mentoring and the right personality and the right context for the person who's being reviewed. As far as static versus dynamic, I am more of a static person than a dynamic person. I understand the validity of both. One of the things that I did in the past is malicious code detection. You can't do that with dynamic. I think that static allows you the ability to do more than dynamic does. Dynamic gives you the ability to view in how your state is today, but it also gives you a little misperception, because if you're deploying that application in an environment and your pen tester or your vulnerability analysis software isn't able to find a vulnerability, it could very well be because you have a web application firewall or firewall up in front that's preventing a set of packets coming through. Well, that could work in that environment, but what if the application is deployed internally and you don't have that same firewall or same configuration? Both cases, you're testing against known vulnerabilities and known signatures, so you're only testing what you already know up to a point. That doesn't guarantee you that there's stuff in there that is still broken.
So you can convince, say, like an IA manager to go through this process and not focus as much on return on investment. But how would you market that to someone who wants to get a product out the door, like marketing or?
So I was kind of thinking about that on the way into the conference, actually. And one of the things that kind of struck me was there was a talk yesterday, and afterward, it was about the 110 years of vulnerabilities, or 111, as you pointed out. We're talking afterward, and one of the things that was discussed was the auto industry. If you look at the auto industry, they're building a lot of that safety checks into the cost, and it's getting passed on. Well, that may be what happens at some point, is that we wind up seeing software as a little bit more expensive than it is, but it may also be required. What you also see in the auto industry now is their way of backing products, and it's a very good sales pitch, and I think it was started, I think Hyundai was the one who started it initially, with the extremely longer warranties on their product. So you sit there and you go, okay, I'm going to shell out $30,000 for a car. I'm looking at two cars, one of which is got a 3-year, 36,000 mile warranty or a 10-year, 100,000 mile warranty. That kind of does factor in at some point. So I think that is one approach that companies can take to offset what they may do with an increased cost for the security.
Kind of a similar question to that is, this process of kind of team building seems like it would work well in a traditional software development methodology. With the move toward Agile and Scrum and things that move so quickly, how can you kind of bake these processes around that rapid development cycle?
So again, that's a good question. One of the things with rapid development is your focus point is much smaller. So your unit of deployment is significantly smaller than what your unit of deployment is in a larger, more traditional shop. So you could still run it. There's still no reason to have the tool, not to have the tool set in the IDE as the person's developing it, where they can get warnings and they can get those responses. You still have builds going on every night. There's no reason to not integrate your static analysis into that. You may have to tweak the rule set to ensure that you get the speed that you want to get those builds out. You can still do your vulnerability assessments. Again, you can kind of bake into the rule book how you want to do it. And even with those sprints, at some point you're delivering to the customer a little bit more. You need to take that time to protect yourself. Anything else? All right. Thank you for your time. This was my actual first talk, so it went a little bit better than I thought.